Good morning, everyone. It's so exciting for me that all of you just come here today in the morning. You all woke up today, you got your shower, you got your breakfast, and you're like, all right, it's time for some exciting new things in Houdini 21. And I just, my butterflies and dummy is crazy. And yeah, so the thing I'm going to be talking about today, my presentation is called The Cops Material is Rock Hard. And so if by any chance you don't really know what cops are and you feel kind of like, well, what's happening here? What I'm going to be talking about is just some HeightField updates in Houdini 21 and how you can use Copernicus in Houdini to generate HeightFields and kind of alter them and bring more details to life. But just before that, a little bit of myself. Who is this guy here? My name is Dmitrii. I've been born and raised in Ukraine. I moved to Canada around 3 years ago. I finished a college here at the VFX program. I was lucky enough to start at SideFX as an intern last year, and I was working on multiple projects for content library and 20.5 demo release files. And now I work as a 3D artist in SideFX, making even more content library files and even more demo materials for now Houdini 21. Here you can see some of the projects I worked on. It's very important for me to say that all those projects are almost all of them all the time. They're very collaborative projects, so it's not like I'm taking all the fame here. I worked with multiple people on those, and yeah, you might have seen some of them in 20.5 sneak peek. So yeah, and now let's get started. So, in order for us to kind of arrange what's happening here, just a quick introduction. What is Copernicus? Copernicus is a newly updated image 2D and 3D image processing network that got released in 20.5. And specifically, the main idea of Copernicus is that it's utilizing your GPU to run all the computation and to store all the images you will try to generate. And the thing is, it's really great to use GPU for that because, it's very fast, it's very powerful, and you can achieve quite a good results really quickly. But, this image is 5090, and I don't have 5090, right? So just to be clear, my PC that I use for all the projects I'll be talking about today, I use Linux 3080 Ti with 12 gigs and i9 13900K. Just for you to know like the context of things I'll be talking with. I mean, I hoped I got 5090, but maybe next year. All right. And, in Copernicus, you can see here some of the example files from internal and external artists, and you can do a lot of stuff. So you can see on the first kind of row, you have a bunch of different grunge maps and masks, and you can do textures and character design, and even some, if you look in the right upper corner, some live stuff now in Houdini 21, which I'm not covering today, is going to be later today, so stick around. But in general, no matter what you do, no matter if it's just a texture, if it's compositing work, you will always start with some sort of input. You will eventually, at one point, align some effects onto your image. Like here, for example, you can see I take my render and added some blue tint using depth map. And then at some point, you will use some masks until you reach your final result. So that's how Copernicus works in general. And now HeightFields. So HeightFields is also a very powerful toolset in Houdini, which lets you create different terrains and environments. You can see here. Some of them were done by me, some of them were done by other people at SideFX. And currently we have a bunch of tools in HeightField toolset bag, and you can see here those are newly added erosion tools in Houdini 21, and I'll be covering more in depth what exactly is new with them, but a bit later. But for now, every time you generate a HeightField, no matter what, you'll probably have some input to begin with. You'll add some effects, right? And you'll use some masking, especially with HeightFields, right? Like you have to use some masking, and you'll reach your final result eventually. And I was like, that feels familiar, right? It's maybe, maybe we can take our HeightField creation thing and combine it with Copernicus. And that's exactly my talk today. So I'll be kind of showing you some ideas, some tricks you can use to elevate your HeightField creation, pun intended, with the Copernicus tools and updates. So, for now, in order for us to uncover any new ideas and tools in Copernicus, we have to have some HeightField to start with, right? And the thing is, it's kind of like a rule in a life, but specifically in VFX, right? It's very important to have this rule in your mind when it says, garbage in, garbage out, right? So if your input is really, really good, no matter how much work you put in, no matter how much effort you put in, your output will be good as well, and vice versa, right? And with the high fields, it's very important to have your input to be very good, because every change you add, you'll have a cascade, basically, the effect, right, by the very end result. Like you will see all the bad results of your input rock geometry altering your final result. So speaking of rock geometry, it's really important, to have it great. And that's a nice looking rock here. So we can just go straight away, project it to the high field. Maybe add some noises, some quick erosion, some noises once again, some quick erosion once again, and now we have this little terrain. And now we can put it to Copernicus and see what kind of stuff we can make with it. And in order to import your high field to Copernicus, you gotta use sub import and geo to layer. And geo to layer is a node that got updated in 21. Specifically now, you can import all the layers with just one button. And if in 20.5, you'll have to create different geo to layer for each layer. So now you can see we have all the layers just in one node, so it makes it much easier. I'll show some examples. It makes it much easier to get things going. And you might also see this little thing here. And you're like, oh, what's that? What's happening here? That's a little thing. It's called ear. I'll be covering it a bit later. But yeah, just keep in mind, that's also updates in 21. And here you can see, so in 21, if you have multiple layers from your terrain, you can just import them here in one node. But in 20.5, you'll have to use like a combination of, different geo to layer nodes for every layer, and you'll have to separate them on a sub level. So like it just makes it much easier to get started in 21 when you have to import your high fields to Copernicus. And right straight away, if you look into different layers, you'll notice that your height map is very, it's clamped, right? So you will see up there, it looks very black and white. And after you equalize it, it will look normal. And the reason why it looks so weird to begin with is because like each pixel value will represent the actual elevation of your terrain in a world unit space. And you can see here, like my pixel in that specific corner is 137 of value, and it's quite a lot. So it's a really good idea to just equalize everything to make it much easier for you to add effects and do stuff with it. And let's cover some quick examples. So here you can see I'm using Swirl, and Swirl is a newly added node in 21, and it works as any other Swirl in any other program. It's pretty much straightforward. But here you can see when applied to high fields, you can introduce some interesting kind of rotation patterns on the main cliff. So the thing is, like, that's the whole idea of Houdini, and I think Copernicus in general, that you can just combine different networks and contexts all together until you have a fine result. And it's really easy to keep it going and just experiment and stick stuff together. And this is one of the examples of that. Here you can also see another newly added node called Pixelate. And it does exactly what it says. It just pixelates your entire layer. And you can see now we have kind of stylized high field, just like that. We can also use Quantize. And Quantize will introduce basically some artifacts if you look into high field image down there. But if you present it as a 3D volume, you can see now we have kind of some terracing going, right? And some stepping. So that's already exciting. We can also distort it. And you can see now we can introduce some flow areas to our high field. And, we can go overboard and use scatter shapes, for example, which is also a newly added node in 21. It will be covered more in depth by Omar today around 4 p.m. I think it's 3:45 p.m. But yeah, here you can see I just scattered a bunch of circles on my high field. And again, like, this is the layer of the high field, and I can erode it. I can add other noises from sub level. I can use the tools. Like, it's all interconnected. And it's very easy to just, play around and try different stuff. But today, specifically for this presentation, I'll be covering this project. It's one of two projects I'll be covering today, actually. And you can see here, so I have my high field, and there are some areas of interest, specifically plateau area. They have like kind of some rocks outcropping on each other. For the main cliff, I have some terracing, some stepping happening. And of course, you can see there's some erosion all around. So we'll be covering all those steps, as well as some lighting here. Some coloring and texturing here as well. But let's start with the outcrops. So, if you look into real world examples of outcrops, you can see basically just some rocks sticking around, and it could be something like bulbous, something like that. It could be something like stretchy and pointy, or it could be some rocks kind of blended together. And I really like that example of rocks kind of mix and matching to each other. And yeah, I'll try to replicate that in Copernicus. So my idea in general is just to create a rock layer and add it on top of my HeightField, like to make it separate and just independent of each other. And what I do here, just straight away, you can create a stem point. You can create some points in your sub import, and you can scatter some rocks and call it a day. But it kind of looks lame. Even if you randomize that circle, still is going to be in a formal circle. So what you would like to do is kind of create a little kind of solver. And for that, what we can do, if we go inside subgeometry, instead of just scattering a bunch of points and leave it like this, what I'm doing here, I'm deleting every point corresponding to my frame number. So if there should be, basically what's happening here, you can see here it says, not the frame number, right? So what's happening, if I play my play bar, that point will just jump around, right? Because I'm killing all the points except the one that corresponds to the current frame number. And now, here it is. Now you can see our point is running around, and if we go back to Copernicus level, you can see that circle is just alone, because we're not running our network right now. So the idea is to basically slap those circles onto each other and just create like a loop. And when it comes to loops, it's really nice to use some blocks. And blocks were introduced in 20.5, but in 21 they got updated quite a lot. Specifically, we got a simulate button. And what simulate button will do for you, you'll be basically able to create a feedback loop. So specifically here, you can see same example now with the blocks. In those red nodes, I just randomize opacity of the circle and the size of those circles. And right here, I just added to the input layer. And basically what's happening, my output gets to be inputted, and I just create this feedback loop. And for this specific example, you can see I just simulated like 50 frames. And in 21, if you would like to simulate 50 frames, 50 iterations, you will just do 50 iterations, like of the, just run your timeline for 50 frames. But in 20.5, it was impossible to do stuff like that. So you will have to generate all the intermediate frames as well. And basically, I thought it's called factorial, but factorial is when numbers are multiplied by each other. I think it's called geometric factorial, something like a triangle number. Basically, in order to generate the same thing in 20.5, you will have to have almost 1,300 iterations, which you can imagine is quite, a bit slower than just 50. So this workflow of having able to simulate stuff and make it to be adjustable by your current frame number opens a lot of new doors in 21. And again, I'll be covering this later on. But, circles are great. And we kind of got the idea, the fundamental principle of how we can make scatter shapes for our outcrops happening. But let's introduce some randomization for those circles. So here you can see I just add some slope direction and distort node. Then I create this little edge detect here just to calculate the kind of like ring mask around and subtract it back, so you can see here the edges of the shape is kind of darker. So when we project it as a height, you'll get like kind of bulged around, and some noises. I will be using a lot of fractal noise here during this presentation, because fractal noise is your best friend in Copernicus. And also using the same ring kind of shape as a mask, I introduced quantize that I already uncovered before. And you can see my colors got a bit weird, so I just normalize it here, add some more noise, of course. And now if we play it, because I randomize all my values to be connected to my frame number, right? When I play my play bar, you can see now we have random shapes generator. And our network got a bit bigger, maybe even a bit scarier. But now if we preview our final result, we can see we got some kind of rock shape just scattered together, right? And all we have to do now is just to slap it on our input HeightField. So you can see here, back in sub level, I have my HeightField in the mask, and I just layer them together with the HeightField layer node. And yeah, now instead of having very solid looking plateau with no details whatsoever, now I have some interesting details and rocks happening there. And of course, because everything is procedurally generated, I can always go back to Cop network and change my values and see different results. I can change the scale of those guys. I can simulate more frames if I would like to. And it's really, really easy and simple to iterate, because again, it's all on GPU, so it's lightning fast. And now let's see some terracing examples. And you can see, and you can say, we have terrace node in Houdini already. Like, why would you try to recreate it again? Like, why would you try to reinvent the bicycle here? Specifically, there was some things that I wish I could be able to do with that node. For my example, I would like to adjust angle. So you can see by default, if you use terrace node in subs, all the layers just parallel to each other. So I was like, okay, that's kind of, I would like to kind of randomize them a little bit and be able to control which way they go. I would like to also be able to kind of introduce more sophisticated custom mask solutions here. I would like to randomize some stepping, because you can see all those steps, each layer is kind of uniformal. And I would like to introduce some XZ plane noise. So that's all the things I'm keeping in mind. And yeah, we can just go back to Copernicus and try to implement all of it. But before that, quick thing about terraces in general in the real world. You can see it's very various topic. It's a very big kind of umbrella of terms, and you can see some terraces here on this cliff is kind of like low scale, smaller formations. It could be very big, like this particular mount, I think is from Wadi Rum in Jordan, and this cliff is like 600 meters tall or something like that. And you can see those layers happening here, which looks pretty cool. Or it could be something smaller scale, but very various like coloring and stepping and erosion processes here on that last example. So keeping that in mind, let's go back to Copernicus, and you can see now if we plug our layer with the outcrops enabled, you already can see some of the things, the outcrops being clearly visible in our height layer. And what I do straight away, I just calculate the maximum value of the input layer right here. I'll get to that back later, but just keep you in mind if you were asking like what's happening there. It's just my max value there. And so I use quantize, and quantize will introduce very uniformal stepping straight away. So the idea here is just to cut some of the areas of that quantize layer and kind of stack those layers together on a feedback loop. And in order to achieve that result, I use segment by connectivity here, which will basically create a random monomask using the shades of the input. And now if I convert my ID layer to mono layer and equalize it just for a good measure, that like, so I will know that all the colors there are from 0 to 1. I can use remap on threshold operation. And what will happen if it's like 0.5 value, half of all my pixels, half of my layers will just disappear, right? And now I can multiply it back to my quantize layer and stack them together and see what can happen. And if I play it again, if I just connected everything to my frame number, you can see, I hope no one is very subtle here for hypnosis, but yeah, basically my mask is just moving around, and again, it looks very random, it looks very natural. And if I get my quantize layer kind of separated in order to achieve this layer, I just subtract it from the main height layer. So I have my height with the quantized, and I have height without quantized, and I just find the difference between the two. I also brought it down here quite a lot because I will stack those layers together, and it's really hard to see. Like there's actually some values there, but it's just black screen here. So I will kill the bright for now. And yeah, if I multiply it by my mask, you can see now we have those quantized layers happening in just specific areas, and we can just guide with the threshold value of how much of those areas we can have per iteration. And now we slap it back to our height, and you can see already some of the lines appearing on the sides. And what we can do for the last step is just to brighten everything up again, because like this value again, that height map is from 0 to 1, and our HeightField is much taller than that. So I'm fetching the maximum value that I calculated earlier just to brighten it up to original value range. And now if we preview it here, it's kind of hard to see, but now you have some lines happening. And specifically those lines have different variations between each other. And yeah, it's already some result, and we can already control the amount of those lines and be flexible about that thing here with Copernicus feedback loop. And that's brilliant. That's really cool, you'll say, but it's so lame. Come on, like let's introduce some more complexity. Let's make it more interesting. And yeah, for that, the thing is, I would really like to have here is to be able to adjust angle. And that was kind of my cornerstone idea, just to be able to adjust angle for my quantization. And on this example, I just create a simple kind of sphere with a ramp, and I just quantize it. You can see it's very lame. Here now has some stepping happening to it. And in order to achieve that, all I do is just, I create a ramp down there, I add it to my height, I calculate quantize, and then I subtract the same ramp back. And now if I change the value of my ramp, I can control the angle of the entire layer. And there's also this little rotation parameter, so I can also rotate my angle. And this is something Tom Goffelli helped me with, also one of the developers in SideFX, which is a great guy. And I'm very grateful for this idea here. And now if we can, add it back to our original little loop here. And if we preview how it looks like after 50 iterations, you can see now we have a bunch of terracing happening, and specifically they're randomized on y-axis, so they kind of look in different direction, but at the same time, they follow the same angle. So that's already quite interesting for me, and it looks quite fun. And we can go to the next step. So the little next step I would like to share is chipping. So you can see here, it's kind of hard to see, I will just amplify it here. There's 2 layers of input high field and output high field, and you can see here I got some kind of areas be chipped out. And in order to achieve that, you can simply use high field noise and it will work just fine. But the issue with the high field noise in SOP level is that it's 2D noise. And what will happen if you use your 2D noise on 3D high field, you'll have some stretching happening eventually on some of the areas. And specifically here, you can see I have 2D noise applied to the left ramp, and I have 3D noise applied to the right one. And on the left one, it's getting stretched as my slope goes up, but on the right one, it's adjusted to the actual slope of my height here. And in order to have it happening in Copernicus, all I have to do is create this little setup. And specifically, you create a position map, you channel split it, and then you replace your green channel, which is your height, right, with your height map. And now if you preview your 3D noise, you can see here, the 3D, this is just the 3D noise, right? It's just 3D noise layer, but it's already adjusted. You can see some of the high field kind of outline happening in the middle. It's already adjusted to my input height, and therefore we can achieve this result here. This is something I would really like to thank Bogdan. It's just a very great tip here. And yeah, so now as we got our outcrops and terrace and even some chipping happening, we can introduce some erosion. So you can see right away, like if I apply erosion, it looks very much more interesting. We're kind of breaking those very uniform looking terrace layers into something more kind of naturally looking. And specifically in erosion node, now it's erosion 3.0. By default, you will have a bunch of settings you can see on the right, and you can control your hydro erosion, your thermal erosion, and other fun parameters associated with that. But for me personally, I really, the only thing I'm focused here is just those up five parameters here. Specifically, you have this freeze at frame. So if I change it, like right now it's frame 1. If I change it to frame 5, you can see I have more erosion happening. I can also change my erosion feature size and make it smaller, so I have little more deep grooves happening. I can also change spread of them, therefore kind of iterating each groove more deeper. So you can see here the change. And at the same time, I can just make my feature size much bigger. And now it's kind of hard to see, but when I change my spread iterations as well, it will kind of make that deeper as well. And yeah, for my specific example, I really like this idea. Like the way it looks here is just basically just erosion node with all the default settings. Nothing, I haven't changed much, to be honest. And if you go inside erosion nodes, and you will find another Copernicus network there. And if you go inside the Copernicus network, you will find the same good old block network. And you'll be like, huh, which means it's also connected to frame. And I will say yes. And it means that you can have some little time lapse like this. So basically, if you just run your timeline, each frame will be inputted as, each output will be inputted back like a feedback style. And you can see, you can create this kind of nice sequences. But yeah, I'll just stick to this frame here. Well, now we got our terracing, we got everything happening. Let's introduce some colors. And after using erosion node, you'll have a bunch of different layers here. And you can see now we have one big green layer, one big green cable, sorry. And speaking of those cables, basically what cable is, it's just a combination of different wires together. So it makes sense, right? So you have a bunch of those different layers and you can just unplug them all. This little ear is also called output of all inputs, I believe. And again, I won't be covering this very deeply because like it's in other people's talks today around 3:45 by Omar. But specifically here, you can see some of the examples real quickly. You can use cable filter, cable unpack, and you can kind of stack them together, merge them together. And specifically, here's the list of all the new nodes associated with cables. And yeah, for my specific example, I use cables only to kill metadata of each layer. So you can see here, I created layer properties and I just, in the type info, set none. So there's no other garbage data associated with my layers. But yeah, again, you can use it for much more things and it'll be covered later today. And now we've killed all our metadata and we got our input layers ready. And what we can do straight away, if you have labs installed, you can right click on your ramp inside Mono 2 RGB and you can sample screen colors. So if you have this little image, you can see here, I got an image of a cliff. I can simply create that node and on the ramp, right click, sample screen color. It will create a snapshot of your entire window, of entire screen. And you can create very sophisticated, very complicated ramps in no time. And that's very handy when you, before that, if someone doesn't know what labs is a kind of package created by SideFX as well, kind of on the side. It doesn't come with a Houdini by default. So what you have to do, you have to go to Houdini Launcher and just install it into under Labs Packages tab, or you can go to Houdini documentation website to download it from there directly. Excuse me. All right. So yeah, that little feature, again, like just a little drop down, right? That little feature will help a lot when you want to kind of look at your HeightField and kind of generate different color solutions. And you can see here, I just like found a bunch of different pictures of cliffs from online, sampled their colors, and yeah, you can kind of create stuff like this. I really like this example here, so I'll stick to that. But you can see for now, it's very, it's just some layers, some colors is kind of boring. So what we'll do straight away, I will distort it. And I can distort it easily because my erosion node will generate flow direction vector paths, and it will generate flow masks. And I can plug it to my distort node. So this is flow direction, this is flow mask. And I can plug it to my distortion. You can see after I unbypass it, those layers kind of get like eroded down. All those colors kind of like smudged together. And you can also adjust like the scale of your distortion if you would like to achieve something more crazy looking. And yeah, I'll keep it more simple. And for some little details, you can also use curvature node, which is also updated in 21. It's a new node coming in Copernicus. And you can see here, you'll basically just find a bunch of highlighted angle areas, edges areas, of your features. And if you plug it back on top, basically what I'm trying to simulate kind of like weathering effect of my rocks. And after that, I can just create height to shadow, and just to kind of like shadow some of the areas around my HeightField for some extra details. And yeah, just like that, very simple, very easy. You can generate some stylized, nice little looking terrains. And again, it's very easy to go back and adjust everything because everything is just procedurally generated. And with no any external textures or files needed. So this is pretty cool. The thing is, I would like to mention all those projects that I'm covering today, they'll be in Content Library, which is a website with a bunch of different tutorials and resources you can learn Houdini with. So if you would like to try this project on your free time, you can be more than welcome to go to the website and just download it. And now, second project here. So on the previous project, again, we covered a lot of erosion tools and custom tools generation for HeightFields, but my texture was kind of simple, right? This project here, I created just to showcase even more things you can do with Copernicus, specifically more in-depth texture creation and some little compositing tricks you can do. So this is the final render, and in order to achieve that, I will just really quickly start with my HeightField. I created a sphere, I created my HeightField, and created a mask. You can see kind of bump it around and added some noises. Then using the same sphere, the same mask, I shrink it down to generate some of the areas for the inside. And again, some more noises, a little bit of erosion. You can see here, like those areas a little bit like blurred. There's so much wind or liquid erosion happening on the moon. So I try to be kind of careful with those to make it a little bit more realistic. And then I'm using the same layer, the same mask layer to generate a little ramp here. And I subtracted from my original HeightField just to create this little dent. And again, the thing is, because everything is connected to just one sphere, I can easily just, put that sphere in different locations, just scale it down or up, and everything will just automatically update. And yeah, for the insides, I add some terracing we already covered. Again, a little bit of erosion, some more noises to the sides. And just with a little touch, I add some kind of like pod and rover models. I got them from NASA website. It's actually great. They have a lot of really cool 3D resources there. And now if we go back to Copernicus and we can just plug everything back to our layers. And from straight away, I knew that my network will be quite large. And you can see here, I created a bunch of those green null nodes. And what I can do now in 21, I can just fetch my layers around. So there is a Houdini called fetch node, and we can simply add input layers together without needing to have, spaghetti of cables and wires. That's pretty cool. But also my input is 4K, right? And you can see I have this little line of resample nodes. And the reason why I add those here is because I don't have to keep all my layers to be 4K, right? Like for example, I'm a mask for the flow. I don't really have to be so precise. So you can easily just resample those layers down to save up on your VRAM and, just to be organized and kind of mindful about your resources. And so I fetch my height here. And what I do right now, I would like to introduce some more details for my height. So I use the same outcrops idea. You can see here, I just added back a little of details on the upper one, just a little bit of rocks. And then I use scatter shapes to create a bunch of circles, and I blur them around to kind of generate dense, little like small craters around one big mama crater. And now, we can do some coloring. And specifically here, I grabbed some textures from Polyhaven, and they recently released a very nice vault of like moon textures, and they're kind of just like gray. But I assure you they're full of details. I just scale them up a little bit with the hex style node to be precise with my scale of the actual crater. What I do here specifically, I fetch a bunch of different masks. I fetch my debris, I fetch my sediment, and I just multiply it all and kind of create this sophisticated shade of gray. And I can continue now with some texture happening. I fetch my height once again, and I calculate dilate. I use dilate now to calculate kind of this, like you see, kind of little shadow masks for my height input. And if I invert this layer and I find a difference between the two, basically what I can do, I can create this little kind of edge detect solution here. But the thing is, I could have used just normal edge detect, but this one kind of allows me to have more control of what kind of features I'll preserve. And I'll use it as a mask to darken some areas from my original texture. So before that I also distorted a little bit with my flow direction mask here. So I grab my height, I create this little like shade of gray. I create more shades of gray from my shade of gray, and I then darken some of the shades of gray with the mask that I generated. And we can use some things. We can introduce some tired masks. This joke was sponsored by Thomas Gaffelli. I don't really like this, but like, please look. I'm really sorry. All right, tire marks. So in order to create some tire marks for our rover, I created a bunch of different curves in sub-level, and now in 21 we can rasterize curves. And specifically, you can use basically like very normal geo rasterization node, but just with the layers, just with the curves. Sorry. So you can see I am grabbing my UV for those curves. And now after I created this little patch of a tire mark, I can simply kind of rasterize it on my curve. And it's really hard to see here, but on the final render, it will look something like this. So you'll have kind of some marks happening on the final texture. And now some impact details. Basically what I would like to do is just to introduce kind of like those little, kind of debris floating around from the main impact. And for that, I create this little radial shade of gray. I use this little node to create a direction, this slope node. And I generate a bunch of just static noise, and I distort it to the outside using that little layer. And I do it a couple of times, and then just introduce more details, so it's like everything's kind of uniformly the same color. I use the same little trick with the random segments from my mono, and I amplify those colors a little bit and just add it back to my original layer. And now it's time to just combine everything together. So you can see here, I got my height, I got my debris layer, and I got some other effects happening here. And just as a final touch, I will also like to darken the crater in the inside. So you can see it happens here. And again, some other little adjustments, like little noises and some little details, just for good measure. You can see here, I use a lot of fractal noises again. That's your best friend in Copernicus, right? And as a final step, just to bring more details in a camera level in Solaris, I generate this little normal map. And yeah, just like that, we have a whole bunch of maps ready to be plugged. And after a quick setup, just, I just have one light in Solaris, you can see here. This is my render, this is my raw render from Solaris. So you can see all the mask happening, all the noises, all the normal maps kind of appearing on the sides. But, just to make it a bit more, interesting and stylized as well, I will plug it back to Copernicus. And what I can do straight away is just kind of darken it a little bit. So I darkened my main area. I guess I just touch a little bit. And I also darkened my depth map. So my AOV layer of depth, because my camera is so far away, all the values of the depth map is like 4,000 or something like that. So I darkened it quite a lot. And I can use some kernels I got here on my defocus node. And basically what will create it's a very normal function defocus node. And there's nothing really special. You can see now we introduced very nice darkening, very nice blur to the outsides of the image while keeping the main crater kind of in focus. And you can see here we have our little mask layer, and we can use the mask to even amplify that effect even more, just to darken those outsides, kind of up and lower edge even more. And then some little adjustments like chromatic variation, some glow. I also make it a little bit more blue, and some sharpening and vignetting. And, just like that, we can have our final crater going. And specifically here, you can see a little details, our little rover, a little pod. And again, all of that is fully done in Houdini, and you can easily go back, change anything. You can update it all on the fly. And because it's all done mostly in Copernicus, it's really, really, really fast. So yeah, this is something I wanted to share with you today. So thank you. Thank you a lot. And now I kind of finished much earlier than I should have. So we have some time for questions, if you would like to ask any. Yes, please.
Reason you couldn't raffle about in the engine and you'd spend something else, or the end of it?
To be honest, I haven't even used Houdini engine, so I'm not sure. I never ever used Houdini engine. You mean like to plug it to like Unreal or stuff like that?
Apparently you can. Someone this way.
Oh, okay.
So weird. Yes, apparently you can. So that's it. It's kind of really interesting. I'll watch what the map can be created. In my experience, the sort of...
Oh, sorry. Hi. I was wondering how large of a map can you create? Can you kind of create a really large map with various level of details, reduction and stuff like that?
So in my personal experience, I tried to keep it under 8K. So 8K is the largest one I went to. Just because like for those specific projects, I don't really have to get 16K or 32K. I think it's possible, but you'll probably have to tile those layers down and kind of create like a little setup when you apply your effects and noises, but it's just in a tiled fashion. But yeah, I think it should be possible.
So why not? It's possible to stitch them.
Yeah, of course. Yeah, we have contact sheet node in Copernicus, so you can just add those layers together if you want. Yeah, thank you.
Can you import directly from lobs instead of having to... Oh, sorry, thank you. Can you import directly from lobs instead of having to go through SOPs if you wanted to use it for texturing directly?
You can create... Usually what I do, if I need just some quick textures done in lob level, I will create a Copernicus node inside my Solaris, and I can just use OP to kind of reference the texture I created in Copernicus. Yeah. So I mean, like, it's not exactly what you're asking for, but you can kind of have a live link from Copernicus to your MTLX shaders straight away in Solaris. Yes.
Tick. Seeing as the Copernicus is being used in some of the HeightField work already, like the new erosion, though they use it burn. I'm curious, have you been talking with the team about making use of some of the details that you're achieving, by hand here at Copernicus? Is any of that going to end up back in the standard HeightField Terrace node by any chance?
I don't really know for now. We don't have like a roadmap for those kind of tools, but yeah, I know if people are very into that, maybe eventually.
register interest here.
All right.
Situation, but now into just a node, so you can.
Yeah, that would be great. That's something I would like to see as well. So yeah, maybe eventually.
Besides the quantize and other like equalize and normalize nodes, are there other hidden gem nodes that you think are underutilized, or things that you can, use one node in a different way to get a, better result?
Yeah, frankly, there are so many nodes in Copernicus even right now, right? I think I haven't still used all of them. So I don't really know. It's kind of, the thing is you can also combine those nodes together, right? So it's even more things to explore. Yeah, I think I covered all the things I really found exciting in this specific presentation, but maybe at 3:45 is going to be another talk about Copernicus and new tools in Copernicus. And yeah, they'll be uncovered in more updates and more new gems in Copernicus. Maybe you can use those as well.
Wait, thank you.
Thank you.
Can you create in Copernicus something similar to HDAs or subnetworks where you can just create a little bit of a tool set and then just save it out and reuse it as you go?
Yeah, you'll have to pack it as your sub network in sublayer. So basically in a sub, you'll create a Copernicus node and you can then pack it to subnets. And yeah, you can, that's basically what's happening inside Erosion, right? The Erosion node is just an HDA with the Copernicus network stuck inside. And yeah, you can just expose the parameters. That's something I also actually tried to do with the Terrace setup, just to pack it and have some of the parameters up there just for me to easily iterate. So yeah, in a short, yes.
In your sort of journey learning this system, how long until you kind of felt comfortable was like 4 or 5 nodes that you use over and over again? So how long do you felt comfortable in the system, or what was your like learning ramp?
Yeah. Basically just, some of the evenings I'll be opening the menu, I'll be like, what's this node? What can I do with that? Or how can I stack it here? Can I stack it there? It's just basically in order to learn Houdini and Copernicus in general, you just gotta experiment and try something. And basically, if you try to keep it outside the normal fashion of just like, using this node for that, using this node for this, you can achieve very interesting results and kind of, accelerate your experience, curve. And you can learn a lot of things by kind of looking at some nodes, some techniques from like different perspective. So yeah, I would suggest just to try things out. Yeah.
Now, I was asked, when you were scattering the point additions to meet your randomized circles and opacity, I was curious, so does the default scatter cheat mode not allow for randomization of position or randomization of other parameters like that? Just wondering, do you have to go through subs in the fashion that did, which it clearly gave you a lot of control, but I was just curious if there's not a built-in node that just allows for overlapping stamping of a shape.
I think you actually can. The thing is, I worked on these projects during the dev cycle, so a lot of things kind of changed. I believe you actually can, yes. But again, yeah, it will be covered in very deeply in 3 hours.
Can you import attributes that you have in a geometry? Say you have an attribute that you made in subs and import it as UV maps for some sort of usage.
Yeah, you will have to rasterize them. So basically you have to convert them from regular attributes from your points or polygons and rasterize into 2D layer. And using rasterizer node or I think in GeoT layer, yeah, you should be able to. Because that's exactly what's happening, right? Like all the mask layer and debris layer is just a bunch of attributes created by erosion node up there, and we can just rasterize them to edible layer. So yeah.
Thanks.
All right. I think that's about it. Thank you again. Thank you so much for coming here today. Yes.